In this lesson, you'll learn how to identify and use basic postulates about points, lines, and planes, and write paragraph proofs. How were postulates used by the founding fathers of the United States? The U.S. Supreme Court Justice William Douglas stated, "The First Amendment makes confidence in the common sense of our people and in the maturity of their judgment, the great postulate of our democracy. The writers of the Constitution assumed that citizens would act and speak with common sense and maturity. Some statements in geometry also must be assumed or accepted as true." In geometry, a postulate or axiom is a statement that describes a fundamental relationship between the basic terms of geometry. Postulates are accepted as true. The basic ideas about points, lines, and planes can be stated as postulates. Through any 2 points, there is exactly one line, and through any 3 points not on the same plane, there is exactly one plane. Some snow crystals are shaped like regular hexagons. How many lines must be drawn to interconnect all the vertices of a hexagonal snow crystal? Well, from the first vertex, I could draw 1, 2, 3, and then I could draw 4, 5, 6, 7, oops, I already counted that one, 7, 8, 9 on the inside, and we had 6 on the outside, so 9 plus 6 is 15. That's prettier than my hand-drawn one, but I kind of wanted to do it by hand so you could see the process of counting from one vertex, because otherwise it's kind of hard to count them all. When listing segments, start with one vertex and draw all the segments from that vertex, then move to the other vertices until all possible segments have been drawn. And using colors helps keep track too. You can restate the postulates in your own words, but please get a reference for them in your notes so it'll be easy to look at when you need to. Postulate 2.3, a line contains at least 2 points. 2.4, a plane contains at least 3 points not on the same line. 5, if 2 points lie in a plane, then the entire line containing those points lies in that plane. 6, if 2 lines intersect, then their intersection is exactly 1 point. And 7, if 2 planes intersect, then their intersection is a line. Determine whether the following statement is always, sometimes, or never true. Explain. If plane T contains lines EF and FG contains point G, then plane T contains point G. Okay, I'm writing kind of small, it's kind of scribbly, but there's a little picture of what they said. Plane T contains line EF contains point G. Looks like it works. And it must, because postulate 2.5 says that if 2 points lie in the same plane, then the entire line containing those points lies in that plane. Again, we're looking for always, sometimes, or never true. For line XY, if X lies in plane Q and Y lies in plane R, then plane Q intersects plane R. Okay, I can draw a way where that does not work. So I've got plane Q and plane R are parallel planes, and I could have my line XY going through. Okay, so there it looks like it doesn't work. But 2 planes could intersect, and their intersection is a line, so the intersection could be on line XY. So that's a sometimes. So it could be true, could be false. Line GH contains 3 non-collinear points. Non-collinear means, this doesn't even make sense. Non-collinear means not on the same line, so how can it be contained? So that one's got to be never. I'm not sure how that even could possibly make sense. Undefined terms, definitions, postulates, and algebraic properties of equality are used to prove that other statements or conjectures are true. Once a statement or conjecture has been shown to be true, it is called a theorem and can be used like a definition or postulate to justify other statements true. You will study and use various methods to verify or prove statements and conjectures in geometry. A proof is a logical argument in which each statement you make is supported by a statement that is accepted as true. One type of proof is called a paragraph proof, which is one type of informal proof. In this type of proof, you write a paragraph to explain why a conjecture for a given situation is true. It is always a good idea before writing a proof or solving any type of problem to have a plan. One strategy is work backwards. Start with what you want to prove, work backwards step by step until you reach the given information. The 5 essential parts of a good proof are: state the theorem or conjecture to be proven, list the given, if possible draw a diagram to illustrate the given information, state what is to be proved, and develop a system of deductive reasoning. Given line AC intersects line CD, so C must be at the intersection. Write a paragraph proof to show that A, C, and D determine a plane. Okay, so I've already drawn the picture, and I want to prove that it's a plane. Lines A, C, and CD must intersect at C. If 2 lines intersect, their intersection is exactly 1 point. That was postulate 2.6. Point A is on line AC, and point D is on line CD. Therefore, points A and D are not collinear. Therefore, ACD is a plane from postulate 2.2, as it contains 3 points not on the same line. I'm going to talk through example 3 that's printed in your book because it proves our first theorem for us. Given that M is the midpoint of segment PQ, write a paragraph proof to show that segment PM is congruent to segment MQ. So we have the given, M is the midpoint of PQ, so that means we want to prove PM is congruent to MQ. Okay, from the definition of a midpoint of a segment, PM is equal in length to MQ. This means that segment PM and segment MQ have the same measure. By definition of congruence, if 2 segments have the same measure, they are congruent. So we can conclude that segment PM is congruent to segment MQ. And here's our very first theorem, the midpoint theorem. If M is the midpoint of segment AM, then AM is congruent to segment MB. We use undefined terms, definitions, and postulates and theorems to prove that statements and conjectures are true.